We are going to continue our quest through Module 7 involving exponentials, and we're going to apply it actually to a little bit different area of mathematics. There's a nice tie here, a good connection between some of your past experience involving explicit and recursive formula for geometric sequences. So really just your understanding of geometric sequence. Now, maybe it's been a while since you've dealt with sequences, but we'll define what a geometric sequence is and then some of the key principles involved with it, as well as some of the key notation that goes with it. So first of all, we're going to look at being able to write the explicit and recursive formula for a geometric sequence, and then apply those formulae to a real world type problems. And then we're also going to be able to calculate the geometric mean for a pair of numbers, although I am going to adjust that, and you'll see that in the later videos as to how that actually takes place. So first of all, what is a geometric sequence? Well, any sequence is a set of numbers or a series of numbers that are somehow related from one to the other. So a very basic geometric sequence would be like starting with 1, and then we're going to 2, and then we're going to 4, and then we're going to 8. And you'll notice that there is a multiplier between each of those terms. And a way to find that, which is called the common ratio, we'll call it R, is to take a previous term. So like previous term 2, anywhere in the sequence, by the way, and we're going to divide it into its next term. Or another way of looking at that is take any spot in the sequence and divide it, any of those numbers, like let's say the term 4, divide it by its previous term to get the ratio. So again, this is all review from your past experience. And so what we're finding here in this case, the ratio would be 2. And so we would use that multiplier then to help us determine that really each time we're multiplying by 2 to get the next term. And so this, like the next term would be 16. And then you take that term, multiply it by 2 and get 32. And you would see then how that would continue on. So what we're going to do is take a sequence like what you see here, and we're going to be able to identify its parts. So first of all, like the common ratio, that's that multiplier. In this case, we're going to call it R. So anytime you see R within this text or in this context, I guess, any part of this chapter, this unit, and really it's used a lot in a lot of other curriculum as well. That is your common ratio. And then anytime you see the terminology or the notation A1, that means that's the first term in your sequence. So if you're thinking in terms of the sequence we have up above there, we would identify A1, first term, as 1. Again, the common ratio for that one up above is 2. And so now to be able to write the explicit formula, we're going to get more into that later, but we would use this beginning A sub n, which means the nth term, really means anytime you see the nth term, that means the rule or the formula or the equation. So when you hear rule, nth term, equation, formula, those are all the same thing. Okay. One of our most important parts to all of this is also being able to identify whether a sequence is geometric. That goes back up to the initial example I gave you, like 1, 2, 4, 8. We know that one is a geometric sequence because there is that common multiplier. So we got to test when they're asking us, hey, is this sequence, any given sequence, a number, is it geometric? That's the first thing we need to determine. Well, we know this is geometric or not by taking, again, any term in there and dividing it by its previous term. So let's just go backwards from this. Let's go, okay, well, if we go 30 divided by 15, well, that gives us 2. And then we go 15 divided by 6, that is obviously not 2. So I don't know, what is that, like 2.5, I believe, something like that. Well, we know because of that, those are not the same multiplier. So because R, I'm sorry, let's not say that. Because R in each of these is not the same, it has to be common. R is not common. So therefore, it's not a geometric sequence. So we're just going to, for time's sake here, say this is not. All right, so likewise now, in the next one here, we would take, let's start with 1.5, and we're going to divide that by -3. Well, 1.5 divided by -3 gives you this -0.5. So we got to check, okay, well, is the next one also going to give us -0.5? So we're going to check, all right, well, what about -3 divided by 6? Yeah, we get -0.5. And we'll check one more. Let's go 6 divided by -12. Again, we get -0.5. Because all of those are -0.5, we have this common ratio. Rest assured that this is, yes, we'll just say yes, this is geometric because R is equal to -0.5. Kind of all over the board there with that one. Hopefully you can track that. Certainly wouldn't want to just glance at my work there to determine that we figured this thing out. But if you followed the video and my conversation, and then maybe how you would write yours a little more organized in your notes, you would see that. Okay, in the next video, we're going to continue with, first of all, graphing a geometric sequence, which is pretty basic. And then after that, writing the formula, which is a little bit more challenging. See you in the next video.